All right, chi-squared. Testing variances and standard deviations against population variances and standard deviations. So will you be using your chi-squared charts again? I actually just finished grading the test for the confidence interval, and this is one, tests weren't bad, but this was one of the areas where there were some issues. So please make sure you know how to use your chi-squared charts, because you will need this for the next test. All right. So anyway, chi-squared, the formula is basic. You know, it's n minus 1 times sample standard deviation squared over the population standard deviation squared. N minus 1 is your degrees of freedom. It's 1 minus sample size. So let's look at an example. This is going to be a short video. So here's an example. It says a researcher claims the variance in the number of forest fires in the United States is greater than 140 for a 13-year period. The variance of the number of forest fires in the United States is 146. Test the claim at alpha equals 0.01. Okay, what factor would influence the variation of the number of forest fires? So it's important that we look at what value we're looking for critical values. But let's look at our hypotheses first. So we want our variance to be greater than 140. So because we think that the variance is greater than 140. So we're testing this. So we're looking at the upper end of the values. We need to find, you know, the critical value is going to be at alpha equals 0.01. Now, this is greater than. So your instinct is going to think, okay, so I'm either going to have 0.01 or I'm going to have 0.99. And your instinct is going to say 0.99. But it's because you want it to be in that 0.01 range. So we want it to be greater than 99% of the population. So you want to make sure that this is greater, that you're using the critical value for 0.01, not 0.99. Okay. So just please make sure that when you're looking at your critical value that you're using 0.01, not 0.99. If it says less than, then you would go with 0.99 because you want to prove that it's not in, you want it in the bottom 1%. So we'll use a 0.99. So we'll create, so my chi-squared is 13 minus 1 over, well, okay, there's the formula, n minus 1 over s squared over the standard deviation squared. So 13 minus 1 times s squared, which was 146, over 140, which gives me 12.814, which is not bigger than 26.217, so I cannot reject I do not reject the hypothesis. So I couldn't prove anything. All right, so practice. So an instructor wishes to see whether the variation in scores of 23 students in her class is less than the variance of the population. So now we're going to go less than, so we need to actually look at the 0.95 instead of 0.05. The variance of the class is 198. Is there enough evidence to support the claim that the variation of students is less than the population variance 225 at alpha equals 0.05. So now instead of looking at 0.05, we're going to look at 0.95 because we want the smaller critical value. All right. Now notice we didn't divide by 2 in any way, shape, or form in these two examples because we have because they're greater than or less than. If you have something that is not different, you will have to divide by 2 just like you did with the confidence interval. Okay, pause the video, do your practice problem, and then let's check the solution. So, where's my solution? There's my solution. Okay. So, first of all, we set up my H naught that my variance is less than 225. Okay. My degrees of freedom is 22. The critical value is 12.388 because I'm going to use the 0.95. All right. So, I want it to be less than 12.388. When I compute it, I get 19.36, which is greater than 12.38, so I cannot reject the null hypothesis. And that's it. We'll see you tomorrow.